Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones. Hi, it's product review time, and we've got another LCR meter. This one is the BK Precision 879B, brand spanking new model. Let's check it out. And here it is. Now you may notice the similarity between this BK Precision 879B and many other LCR meters on the market. Now, that's not a coincidence. It's because their original heritage is from a company called Escort. Now, they designed and manufactured a lot of test instruments which were rebadged, not only under the Escort brand, but were rebadged under many different names, including BK Precision and Agilent, as well as many other smaller names. So there's no mistaking, this looks pretty much identical to the Agilent unit and quite a few others you can buy out there. But Agilent actually bought out Escort a couple of years ago. So what that meant was that while the other manufacturers could still sell this meter, they still had rights to sell it, BK Precision decided that no, we'll go design our own and redo it from scratch. So although it still looks similar, this is a completely new design inside. And of course LCR meters aren't that exciting. What we really care about is what's inside. So you know what we say here at the EEVblog, don't turn it on, take it apart. And to get the unit open, there are two screws up the top here. Somewhat disappointingly, they aren't metal threaded inserts, they're just self-tappers, but there's one extra screw under here for the metal, but this is a threaded metal insert for the battery compartment. So let's lift it off and take a look. Ta-da! Here it is. And it's actually very, very nice. Let's check it out. Let's take a general look around the unit. There's two main devices up here which we'll take a look at. There's some very interesting looking headers over here, presumably for in-circuit programming, which we'll check out. You've got three input terminals down here. One's the guard terminal, one's positive and negative. You've got the 9-volt battery terminals straight on here like this. I love those. And so there's no wiring at all in this unit. It's just a single board construction. Now, they've got the USB connector down the bottom here. Now that USB connector has got to connect to these devices up the top, so why it's right down there, a high-speed USB serial interface, right down in the bottom corner near the terminal. In this case, it's the positive terminal over there. Why they put it down there instead of up here somewhere, right next to the devices, is beyond me. That just seems like a crazy layout decision. I'm not sure what they were thinking there, but anyway, the only adjustment in the whole thing is a nice 10 or 20 turn pot down here, as you can see. And it looks like that's the only adjustment at all. There's a few missing components down around here. Here's the 12-volt input jack. This is obviously the DC to DC converter input circuitry there for the external power supply. And these, take a look at these diodes down here. They're actually the incorrect footprint. So they've designed it for a bigger footprint like these, but they've decided just to use these MELF packages. And we have a large spring terminal here which goes up to the shielding on the back of the case. So the shielding sort of wraps around the sides. It looks very nice, no problems there at all. Now the input circuitry here, there is actually a fuse. I was expecting like a glass fuse like most other LCR meters has, but there it is. There's F200 down there, so that's actually some sort of poly switch or something like that. So it does indicate on the display if the fuse is blown, but that's obviously not easy to change. If you do overload the inputs and you blow the fuse, well, you may not be able to replace that. So I'm not sure if it is a poly switch, though, it'll be a self-resetting poly switch, so that would be good. But if it's just one of those surface mount fuses, then that's not so good, because that sucker's not going to be easy to change at all, unless you've got the gear to do it. And if we look at some of the other circuitry here, you can't read those numbers, but there's lots of discrete op amps, lots of 4000 series analog CMOS stuff, as is very typical with these class of LCR meters. They actually require quite a fair bit of discrete circuitry, and I like it. It's really quite a neat layout. It's no problems whatsoever. I don't see any bodgy components at all. It really looks quite nice. Now, I got one of the first meters which rolled off the new production line for this model, and as you can see, it's already up to version 2.2, copyright 2010. So they've gone through quite a few revisions before they actually got the product out the door, which is a sign that they've actually refined this thing and it works really well. Now, these are the two main devices up here, and it's got two crystals. Looks like a 32 kilohertz watch crystal down here and a standard crystal up here, which is 6.4 megahertz, I think. Yeah, 6.4 megahertz. And these two devices, interestingly, I didn't expect to see an Altera Max 2 device, and check it out there, if you can read the number on there. So, and this looks like a standard Altera JTAG header. So what I did is I hooked this up to my to a JTAG programming interface in Altium Designer, and bingo, there it is. It popped up. As you can see, it's the Max 2 EPM 240T100 ISN CPLD. I like it. So obviously this thing is going to be quite hackable. You can reprogram the JTAG in this thing. You can read it out. You can make mods if you want. Now this micro here, it's a TI. I presume it's a micro. It's a TI1, and I don't recognize the part number at all. I'll have to, yeah, you should be able to read that. But offhand, I don't recognize it, so I have to look that one up and see what it is. But what the second CPLD there is doing, the Altera one, I don't know. But obviously they deem that they require two devices. So obviously this thing is quite hackable and quite powerful. This is obviously another serial JTAG or in-circuit serial programming / debug header. So you can do some great stuff with this. I like it. And here's the input jacks. They're quite unusual. At first I thought I really liked them. They sort of looked really good, and I had no issues with them. They got a tiny screw down here, but they're molded inside here. So you unscrew them. They've got a single piece of folded metal which does the blade input terminal. But look, there's another tiny piece of folded metal poking out, which is then soldered onto the board. So the reason I don't like it is because if you insert something into, if you insert a component continuously into blade, you can see that blade actually moving, and that is could eventually wear out that solder joint or break it off or crack the joint or something like that. So I don't know, maybe BK Precision have done their research on that and tested it thoroughly, but I don't know, I would have liked to have seen a different interface, either discrete wiring going over or something like that. So not entirely trustworthy of that, but I'll give them the benefit of the doubt through long-term testing. Just as a very quick reference, here is the old Escort design, and as you can see, it's quite lower tech. It uses older devices. There's no CPLD up there, and no USB interface either, and there's lots of discrete circuitry up there. And as you can see, the device down here, if you can read it, it's going to say Escort on it. There you go, Escort. So overall, I really love the new redesigned circuitry. They've really completely redone it from the ground up. It's a nice layout. It uses nice modern components and surface mount caps. I love it. Big thumbs up. So what do you get in the box with the 879? Well, let's check it out. Ta-da! We get a manual, which is pretty good. We'll take a look at that later. I don't mind that at all. We get the meter, beauty, with an installed battery. We get a plug pack, a real old-fashioned transformer plug pack, which is 12 volts, 150 milliamps, but it's 120 volt. So I didn't get the one for the Australian market, presumably, but you get the plug pack, which is great, and you get a mini USB interface cable, but that's it. There's no software. You download the software off the internet, which we'll do later, but that's it. Bit disappointed. Why couldn't they throw in the tweezers? You can get the tweezers for $26 extra. They could have thrown that in. That would have been beautiful. And it's $299 So it pretty much puts this meter probably smack in the middle of the LCR meters on the market. There is a lower model to this too, the 879B, and it pretty much doesn't have ESR and a bunch of other useful stuff, and it's not that much cheaper. So I'd recommend spring in, if you're going to get this model, for the top of the line 879B. So what are the headline specs? Well, They've improved this model over the existing Escort design in that the primary display is now 40,000 counts, which the old one was 20,000 counts. So you get twice the number of counts, which is really useful. It means you can get a greater resolution for over a more useful range. So if you measure a 39 nanofarad capacitor, you'll get an extra digit of resolution over a 20,000 count meter, which is awesome. Now the secondary display is 10,000 count, which is still pretty darn good. It's got USB interface, which we'll go into. It measures up to 10 kilohertz, which the cheaper LCR meters won't, so that's real handy. And the headline specs are 0.5 base specs, 0.5% plus 1 count. So it's really super duper accurate specs, better than the more expensive ones on the market, which will have, they'll be 0.5% too, but they'll have a higher plus count. I was a little bit disappointed that it didn't come with a calibration certificate. That would have been really nice. For 300 bucks, you get into the borderline where you might expect a calibration certificate, but you do get a 3-year warranty with it, which is pretty awesome. Let's take a look at the unit overall here. Now, it's a really nice fit in the hand. It's got the nice curved design on it. It's the original Escort case basically, and it still feels really nice. It's got the rubber holster around the side, and it's got a very nice tilting bail on it. It can sit, well, it sits like that, and it really is quite stable. And yes, you can push the buttons without the thing falling over, and it does actually, I'm not sure if this is a feature, but it does actually snap back even further to give you a much shallower angle like that. I'm not sure if it's supposed to do that, but it does. And the battery compartment, as I said, in the back, so you can access it, which means that you don't break the calibration seal, because when you get these things calibrated by a professional lab, they'll typically put a cal seal on here, and you want to be able to change the battery without doing that. And as you can see, it's got some polarizing hooks in, some polarizing tabs in there, which allow you to only insert the battery the correct way, although you can actually put it in, but you can't close the back on it like that. So it really only lets you put in the battery one way, which is great. It's a nice design, and I like it. It feels really quite solid. I haven't put the extra screw in there yet for the battery cover, but it really feels like a nice solid unit, and it could survive the knocks in a general lab. On the side here, excellent. We've got a standard Mini B USB connector. I love it. It's not optically isolated, so that is one disadvantage of this. So if you do require optical isolation on your LCR meter or your test gear in general in a lab, this one is not going to be suitable for you, but it has a great advantage: high-speed USB interface, standard connector. I love it. The input terminals down here, it's got a guard input terminal, which you may not get on the lower cost instruments, which is great, which allows you extra shielding when you make up custom test leads to go off to a production test jig or something like that. It's got the blade input terminals up here for the through-hole components, and it's got standard leads down here. And I forgot, when I did the unboxing, I forgot you got the leads as well. You got the standard clip leads that plug in here. They have a nice, not an entirely really tight fit, but a reasonable fit nonetheless. You don't get any guard terminal because that's only for custom leads, but these are quite reasonable alligator clips. There's an extra nice touch they've put up here, which is this display guard. It's designed for when you put the meter flat on the bench. If it lands or falls flat and gets dragged across, it doesn't scratch the display screen. And let's give that a try, shall we? There it is. As you can see, under there like that, the display is well and truly not touching the bench. So it's a rather nice design. I like it. We'll power up the display and see what we get. If we hold down the power button here, as you can see, it tells us firmware version 2.0, and it's the model 879B. Quite neat. Now, if we have a look at the display up here, as you can see, we've got a primary display, as I said, 40,000 counts down here, with a 10,000 count secondary display up here. And they correspond with the primary display button down here, primary functionality. You can measure inductance, capacitance, resistance, and impedance. And the secondary display can switch between dissipation factor, quality factor, phase angle, or ESR, which is pretty much full-fledged functionality for an LCR meter such as this. Let's try the standard GSM mobile phone interference test. Now I'm measuring a standard cap here at just over 100 nanofarads, and I've got my phone here, and as you can see it's calling the thing. As you can probably hear the interference, the GSM interference through the microphone there. I'm sure you can. I don't even need to play back that. I know it's going to interfere, but look, it doesn't change the meter at all, even if you put it right over the cap. Nothing. So it's really is quite nice. It's totally immune to GSM interference. I like it. I must say I'm not a huge fan of this display because the contrast isn't that great, and the segments are really quite thin, and it's quite glary, but that's no different to other. This is pretty extreme here in the lab, this glare which you see in there, but that's not much different to the other LCR meters I've got. But yeah, I'm not a huge fan of the display, but it's certainly more than adequate. And of course it's got all the indications and functionality you require with the dual display and everything else, so there's no problems there. It's just the readability side of things. Now, there's one thing I really like with this is the relative mode. Sure, all LCR meters have got a relative mode on them. They have to. It's a vital feature. But this one, as you can see, I'm measuring 100 nanofarads here, which is a reasonably high capacitance in the scheme of things. And if I press the relative button here, as you can see, it continues to auto range. It's jumped down to 3 around into the picofarad range down there. It's awesome. Other LCR meters I've got will not auto range. They will, once you hit the relative function, they will stick on that one manual range. So that could be really, really useful. One of the awesome features of this meter is that can go down to 100 microohms resolution, or 0.1 milliohms. Let's check it out. I've got the leads here. Let's short them together. It's not terribly quick auto ranging, but I wouldn't say it's slow either. There it is, 0.06 ohms. And if we hit the relative function, there you go. Look at that. Fantastic. And that's reasonably stable considering we're using the alligator clips and you wiggle the leads around here. That's pretty darn impressive. Super fast auto ranging. This is a 2200 microfarad cap. Okay, let's check it out. It's on picofarad range. Okay, it's auto ranging. Let's plug it in. Bang! It jumps straight to 2.2 millifarads. Awesome. And as you can see, the ESR resolution is excellent. And of course, the secondary functionality up here goes from ESR through to quality factor, through to dissipation factor, and phase angle as well. And just to make sure it's not lying to us, at 120 Hertz, I've got it in parallel measurement mode here, and I'm measuring 2.157, it's jumping around a bit, millifarads on this 2200 microfarad capacitor down here. But let's see what we get when we go to impedance mode. Now at 120 Hertz, 2 times pi times f, 120 Hertz, times 2.15, let's call it 4 millifarads, okay? Invert that, and we should get an impedance at 120 Hertz of 0.1657 ohms. Let's try it. There you go, 0.163, which isn't too bad. That's certainly within tolerance. And it's got a backlight too. Let's try it out. You hold down this button here and bingo, backlight comes on. It's nice and even. Let me turn the lights down there a little bit, and it's pretty good. I like it. Nice even backlight. And if you go into the utility menu here by holding it down, you can see that you can turn the beep off and on, and you can turn the auto power off 5 minutes, 15 minutes, 30 minutes, 60 minutes, or off, and that's really handy. I like that. And this mode here allows you to store the power up settings. So if you want it to power up at a specific frequency with a specific secondary display and in a specific measurement mode, you can do that, which is quite handy. It's a bit annoying having to go through here. I'd probably prefer it to do that when you do the power on off button, but that's just a personal preference. But this is quite flexible. And it's also got a calibration mode down here. If you hold down this button, you can do open and short calibration compensation. So in this case, I'm measuring resistance, and I've got my leads shorted out, so I calibrate that, and it takes out the test leads effectively. There's a bit of tolerance there because there's a bit of play in the contacts in these crocodile clips, but that's a useful feature. There's one real handy feature, which is the tolerance mode down here. Now it allows you to measure components relative to a reference component. So let's say this capacitor down here is our reference component. It's 100.06 nanofarads, but it doesn't actually matter what it is. You press tolerance and bingo, now we can sort. Up here it shows the tolerance that we're out. So let's take some other capacitors which are the same value, but they're going to have, this one is 0.15% higher than the reference one. This one is 1.85% different, as you can see, higher, and this one here is 0.34% difference. And you can enter different modes. You've got 1%, 5%, 10% and 20% modes as well. And as you can see, I've got it set to 1% tolerance mode here, and let's deliberately put in a cap that's out of tolerance, and it will do several beeps instead of the single beep which you'll get with one that's within range. Great. If you take a quick look here at the manual for the automatic fuse detection we looked at when we opened this unit, it does tell you error fuse, and it basically says, it doesn't say it's replaceable, it just says contact B&K precision for assistance. So it looks like that is probably an SMD fuse in there and not a resettable poly switch. Now if you take a look at the manual here for the capacitance range at 10 kilohertz, there it is. These are all the different ranges at this particular frequency and the measurement modes, series for all of them. But it says if you go down here to parallel mode, it has a 40 picofarad range, which with a 40,000 count meter is phenomenal. It gives you 0.001 picofarads or 1 femtofarad resolution, which is awesome. But that's what it claims in the manual. But if you go here and you go into the capacitance mode, as you can see, picofarads, 10 kilohertz, we're in parallel mode. Bingo, it's not. It's not 40 picofarads, it's only 400 picofarads. So the manual's lying. Where is the 40 picofarad mode? And the same thing with the inductance range, 10 kilohertz down here in series mode. Let's have a look at the actual meter. It says it should do a 40 microhenry range. There it is. But let's go down here and put it in parallel mode, series mode, 10 kilohertz. Inductance, we're not. We've only got 400 microhenries. Manual's lying again. And let's take a look at the specs in a bit more detail. Now, as you can see, all LCR meters, or good ones, will give you an accuracy table like this for each different range of measurement value. This happens to be the inductance versus frequency. So they'll give you a whole bunch of different tables for all the different frequencies for all the ranges. And this is not surprising that the best accuracy is typically obtained in the middle, around the middle ranges here. So as you can see, it's 0.5% plus minus 1 count, which is awesome, absolutely awesome for a 40,000 count instrument. I love it. But as you can see, it starts getting 0.7% plus 2, 1.5% plus 3 up here, 2.8% down here for 4 millihenries, and so forth and so on for all the different ranges. So if we go to the capacitance over here, here's capacitance at 100 hertz, 120 hertz, and as you can see, 0.5% plus minus 1 count, but up in 20 millifarads, which is a huge amount of capacitance, we're talking 8% plus minus 3, or 2.5% down here, and tells you which mode you've got to use, series or parallel. So a bit of a trap for young players, specifications on LCR meters. You can't just say, oh, it's 0.5% accurate. You really have to talk about the range and the frequency and the mode that you're actually using. Now there's one thing I just cannot figure out. Now I've even read the manual on this, okay? I had to actually go to the manual, which is the recording function, or the MinMax Average functionality. Now, to show this, that I don't know what the hell's going on here. I've got the original Escort design here, the Agilent / Escort design. Basically the same meter, okay? Essentially like functionality and breeding and all that sort of thing is exactly the same. This one is derived from this. So the functionality, you'd think it'd be very similar. And if you read the manual, it's exactly what it should be. Now, if I enter, let's try the BK Precision. I enter Max Average Min mode. There it is, across there. And I plug in a cap. Okay, no problems. It recorded. I plug in another one. it recorded, plug in another one, it recorded, okay, and I hit the record function, nothing, absolutely no, it stays in MinMax Average mode. Now, I can actually get it to do this. Watch this, I'll try it again. It seems a bit temperamental, but if I try it, there we go, it's taken a recording. Let's try it again. It's taken another recording. Let's try another capacitor. And it's taken a recording. Now, if we hit the record mode, there we go, max, okay, 100.18. It's not changing at all. It has not recorded those values whatsoever. Now, let's take a look at the Agilent over here. Let's turn this one off. Sorry, well, let's switch into MinMax Average mode and let's do it. Okay, bang, it's recorded one. Let's do another one. Bang, it's recorded. Let's do another one. It's recorded, and one more for good measure. There we go. Okay, now if we press the button, max was 99.99, min was that, and the average was smack in the middle. So what's going on with this BK Precision? It doesn't, that's how you'd expect it to work if you read the manual, but it doesn't. Let's try another method. Instead of disconnecting completely, we'll go into recording mode, and I'll plug another one in parallel. Bingo, it's recorded. It's recorded, so it should have enough data to get max, min, average. It sticks with the one value. It's crazy. I reckon there's something wrong with this, unless I'm completely dumb and I don't know how this functionality works. Beats me. One other difference with this new design over the original Escort one is that it had a manual range override, so it would actually allow you to go in and manually change the range. You don't have a manual selection capability on this new model BK Precision, or not that I can find anyway. It's only got auto ranging, which is great for most of the time, but when you need that manual ranging, it's really annoying that it only has auto ranging. Now, the manual that comes with it is really quite nice. It's all in English, of course, and it's got pretty much everything you could possibly need, including the USB command modes. It's actually a serial port interface, but as you can see, here's all the serial commands for controlling the instrument. So you can write your own drivers for Linux or for any other serial equipped machine you like. It's great. Now let's do a basic measurement on a 1 millihenry inductor here, and as you can see it's got an ESR of 2.6 ohms or thereabouts. Let's see if we can fool that by putting a 10 ohm resistor in series. If we clip that on there, and no, we can't fool it at all. There it is, 12.9 ohms and still 1 millihenry. Now, I won't bore you with all the details about how I measured all sorts of components over all sorts of ranges, and it seems to do exactly what it's supposed to do. And spec-wise, I don't have any real high precision, high stability capacitors and inductors to do absolute reference measurements with, but comparative measurements with other LCR meters I've got show that it's spot on, and really I have no doubt it's going to meet its manual specifications that are in the manual over all the ranges. So it looks like it's a really high-spec instrument. I like it. And here's the PC software. I've got it hooked up via USB here, and you have to install the drivers. You can download the drivers and the basic control software from the BK Precision website. Now, I had a bit of an issue here because I installed the driver software and it told me that it set up this serial port because it is actually a USB to UART bridge driver. So it set mine up as COM number 8, and if you go into the software here, it only supports up to COM number 6, so that's something to watch out for. I had to manually reconfigure it via Windows to COM 5. So if I go to COM 5 and connect, bingo, it showed up as remote on the LCD there, and we can measure. I've set it to auto update here, and it's reading the primary and the secondary display from the meter, but look at the resolution, check it out. It's 0.1 femtofarads. It's phenomenal. And it looks like you can get much greater resolution than what you can get on the display here. This is really remarkable, and it could come in real handy. And basically, this is just a simple control program. You can basically control all the remote interface on this, so I can measure capacitance, or I can go in and measure impedance, or measure inductance, or anything like that. So if I stick my capacitor in there, and I measure capacitance, there it is. It's popped up, and it gives you much better resolution than what you can actually get on the display. Check it out, 98.25. I've got an extra digit of resolution here. And you can set up the measurement mode, series parallel, the test frequency, of course, you can change all that. And you can do the tolerance values as well. The only other thing it does is it allows you to record data. So if I hit the record data thing here, and I can view the log data, there it goes, and it brings it in full resolution. Check it out, which is phenomenal. And then you can just stop that in the background. So we'll stop that there, and you can save it to Excel and text format. Beauty, I like it. It's an awesome little control program. But the good thing about the serial commands on this is that they are SCPI or SCPI compliant, which is stands for Standard Commands for Programmable Instruments. So it has a standard interface, fully documented. You can write your own drivers for it for any control program you like. Awesome. And the serial port driver is actually the Silicon Labs VCP driver, so it does support everything up to Windows 7, which is what I'm using here. And let's do a quick check of the battery consumption. Now, the MetroHit Energy here is measuring the battery voltage. The MetroHit Extra here is measuring the input battery current. I'm powering it from my external supply over there. And the specs are actually in the manual, and it tells us that it draws about 28 milliamps with the power on and 2 microamps power off. But as you can see, it's only drawing 0.5 microamps in standby mode, so that's excellent. It easily meets its spec there, and just in regular mode it's only drawing 17 milliamps. So much for 28. So the specs are way out. Let's measure a capacitor, see if it makes any difference. There we go, 17.6 milliamps, no problem, at 9 volts. And it tells us that it drops out at 6.8 volts, which is pretty good. Well, let's try that out, shall we? Let's wind down the power supply. And we're looking for the low battery at 6.8. Oh, yep, there it is. There it is there. Yeah, and it is about 6.8, as they claim. As you'd expect at 6.8 volts, it's about 22 milliamps consumption, but still way under the datasheet spec of 28 milliamps. That sort of consumption with a 9-volt battery at around about 20 milliamps, it's probably going to give you about 45 to 50 hours of battery life, which isn't too bad for an instrument like this. So what are the maximum measurement ranges? Well, let's check it out. The inductance, we're talking about 1,000 henries full scale, which is pretty darn good. And at the minimum range, it says it's 40 microhenries, but as I said, I couldn't get that. It's only 400 microhenries, but that's still pretty darn excellent usable range. And the capacitance, we're talking about a maximum range of 20 millifarads, which is pretty good. If you need to go bigger than that, well, geez, you're into some serious stuff. And the minimum range, as I said, I couldn't get 40 picofarads, so the minimum range is 400 picofarads. But really, if you're going to need more than that, maybe you can use the PC interface to actually extend that if you really need to. And the resistance only goes up to an upper limit of 10 meg, which is, well, it's not that great really, but you don't typically use these LCR meters to measure high values of resistance. And the ESR down on the minimum range is a 1 ohm range, so it's pretty awesome in the ESR, and the resistance is 4 ohms minimum range. So the verdict on the BK Precision 879B, I really like it. It's probably my pick of the handheld LCR meters. I think it's great value for money at $299. Bit on the expensive side, maybe you could argue, not quite at the hobbyist level, but it's a really awesome instrument. It's precise, it's got a huge measurement ranges, the PC software is really nice, the PC interface. The only disadvantage with that is that the USB interface is not isolated, so if you need an isolated interface for some sort of production work or something like that, it's probably not going to be suited unless you get an external isolator. You might have to go for another instrument. But apart from that, it's a really great meter. It works really well. I like it. But I have no idea what's going on with the recording MinMax functionality. So BK Precision need to look at that and tell me I'm an idiot because I don't know how to use it. I don't know. Go figure. But yeah, I really like it. Check it out.